My name is Andrea Alcantar, and with my teammate Jason Gallegos, we're doing the project about exploring compressive strength in concrete. We decided this issue because we thought it was going to be easier. And I would say for me, the hardest part was understanding our data and starting with the interface because we didn't know exactly what we how were we gonna do the interface. So yeah, and I'm in charge of doing the video and the first part of the project.
Hi, my name is Jason Gallegos. I did the interior report in the last half of the final project. I'd say the part that I struggled with the most on the final project was the data interface because I didn't know how to exactly set it up. But after doing some research and using some of the files that were provided in the final project, I was able to figure it out.
Okay, so the first thing we have to do is to import all the basic modules, which are NumPy, Pandas, and all of the models that we have been working with. Um, these are going to be used all throughout the um, the project. After that, we have to read the CSV file, which was already given to us, and we use the info and describe functions to read info about the data. These are the first five rows. Uh, we can see them using the head function. After that, we have to yeah we have to reformat the models and set up the data model structures. So first we renamed the columns so that it would be easier to work with them. Um, and we used the pair plot function to show correlation between variables and help with specific instances. So this is it. And then there's this heat map which shows where the ones are listed are places with perfect variables. After that, we use this scatter plot to show correlation between specific variables and the concentration of the different elements. So this shows correlation between concrete compressive strength and fine aggregate, and how concentrated are water and H, and the correlation between all of that. And we did the same in this. So this shows the concrete compressive strength with relation to cement and superplasticity and fly ash, and also the density, if you could say, um, between water. Between fly ash and superplasticity. After that, we did the regression models, which show how each model is on a concrete strength scale. So we had to take here we did the root mean squared error, the mean squared error, the mean absolute error, and the R squared for linear regression, lasso regression, and ridge regression. And we collected all the coefficients so that we could do this bar graph, which shows the coefficient value for each linear, lasso, and ridge regression in similar um, water in the water.
After finding the coefficient value for all the components, I then decided to make the scatter plots for the decision tree and random forest. So this code implements a simple regression model using a decision tree regressor. The regression model was trained on a training data set such as X train and Y train, um, and then used to make predictions on a test data set. The performance of the model is evaluated using various metrics, and a scatter plot is created. So, like this, having a regression line running from one end to the other. And then I made a random forest regressor using almost the same code as the decision tree scatter plot, and to compare the actual values and the predicted values. So right here, almost the same thing. Okay, so now in plotting the regression models, I first did um, linear regression, where it scales the input data, trains a linear regression model, uses it to predict values on a test set, and then visualizes how well the predictions match the actual values through a scatter plot with a reference regression line. So right here. And then right here, I use the same code, but I change it for the lasso regression model. And then I repeat this step one more time, but change it for the ridge regression model. Okay, and so this code right here, this code helps visualize and compare the importance of different features in predicting outcomes for both a decision tree and a random forest model. Um, so right here, I created the data frames, I sorted them, and then I just did a simple plotting, annotated the values. That way I could see the values right where the bars are. And so right here, so the meaning of these bars is the longer the bar, the more important the corresponding feature is for making predictions in the model. Now we go into model building. So right here, I repeat some imports just in case and create a list of regression models. This code shows all of the regression algorithms that are right here and the RMSE values for all the different regression algorithms. I then code a bar graph showing the RMSE values and then plot the graph, which it is right here. So there is not much of a difference in between all of these, surprisingly, but the model that I felt like was going to be better for our data interface was going to be the random forest regressor because it had the lowest RMSE. So right here in our data interface, this code creates an interactive tool for predicting concrete compressive strength based on a machine learning model, allowing users to input various concrete mixture features and get real-time predictions. So right here, I create the random forest regressor, and then this is the function to predict the strength of concrete with the different components and their values. Right here is where I create the input boxes so the user can input whatever value they want into the components. Right here, I create a button. That way, whenever we're done inputting the values, we have a way to secure the values and find the strength. Um, right here is just so it could display the predictions. This to get the user inputs, and then this is the prediction, and then all this is displaying the result and displaying the widgets. So right here, this is our data interface. So right here we have a 63.02. If you wanted to change the slag and maybe the water, well then same strength, but change the slag to 200. Oops. If we change the slag to 200, you then get this. And then same thing with fly ash. If you wanted to up that just a little bit and predict the strength, you get a higher MPA as well. So here we could type in different values for all the models. After we put in the values that after we put in the values that we want to test, we then click the predict strength button and it shows the strength that the mixture has.